Well, hey there, everybody. Welcome back to the channel. I'm Adam. Thanks for hanging out with me again today. As the title indicates, this one is kind of for the newbies, or just people that aren't terribly familiar with RC. So where I came up with this idea, Craig from OAGRC posted a video this morning, and basically it was explaining what you need to get when you get an RC car. ESC, receiver, servo, and then he recommended some tools and stuff for building. But basically, we're talking about kits like this. So this is the Tamiya MB-01 chassis with the classic mini body on there. What I'm going to go over today is kind of expanding on Craig's video. So I will leave a link in the description to Craig's video so you guys can watch that as well. But I'm going to kind of expand on, his video explains what things are. I'm going to try to give it how these things work in as simple a way as I can. I'm not going to get into the weeds and explain the minute differences between this and that. It's just kind of an overarching general advisory of how these things work. So the three main things in your RC car that make it go and turn and stop and back up and all that good stuff is your servo does the steering. So this is what's turning your front wheels left and right. And we'll go over how that works in just a second. And then you have your motor and ESC. Sorry, I didn't get these things out of the bag. This one is actually a receiver and ESC all in one, and then your electric motor. Now, I'm just using this as an example. I have different ones here. So this is an older Novak dually motor or dually ESC. Does the exact same thing this one does. They've just gotten smaller, more compact, and more powerful over the years. Now, what your ESC does is it tells the motor what to do, and it gets its instructions from the receiver. So I will start off showing you all this stuff kind of in progression in just a moment. So brief history lesson. In the old remote controls, you had a mechanical speed controller, and this mechanical speed controller used a servo like this, and the arm moved this lever left and right. So when you wanted to go forward, the servo pushed the lever and it moved it to basically a slow, medium, and fast position on here. And then when you wanted to stop, you would come back to neutral and then possibly go into reverse to actually get your vehicle to stop and then go back to neutral. And then same thing, reverse, you would go in the opposite direction and it would go in reverse. These work very, very well, but they were prone to having some issues. The old radio systems we used would kind of glitch out, and if you lost signal, well, the last thing that the servo knew was you wanted to go full throttle. So it's got this pulled all the way over there, and you're desperately moving the controls on your radio, and your car is now just going further and further away from you. So a lot of the electronic speed controllers put in fail-safes to where if it lost signal and it had no more inputs, it would return to the neutral position. The car would idle to a stop and slow down, and you wouldn't be chasing your car for 3.5 miles. All the new ones basically have that fail-safe enabled. If your car loses signal, the speed controller goes, we don't know what to do, go to neutral, and that's where it sits until it regains signal. So, start to finish, you need a radio. Craig covered this. Doesn't matter what radio it is. This is a fancy, multi-model controller, but a generic radio set works. So you need radio and receiver. You are telling the radio what to send to this. So right turn, left turn, forward, brake, and any of your other buttons and stuff on here. This is just sending an electronic frequency to this. These two things are bound together. Now, in the old days, you used crystals, and this broadcast a very specific frequency that the crystal in your receiver could hear. If it was on a different signal, the crystal in here did not care. It just ignored that. Mostly. There was a lot of interference, especially when you started getting very close into frequencies. There was a little overlap, and your car would be sitting there twitching and jittering because somebody else is running either your signal further away or was on something very, very close, and your little receiver is going, huh, what, huh. So your wheels are twitching, your tires are spinning a little bit. These new radios, you don't have to worry about these. These are on 2.4 gigahertz, which is a much, 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 much higher frequency than anything that we ran back then. And the way these operate is this radio knows exactly this receiver when you have it on, and it won't talk to anything but this receiver. So think of it as a phone number. You know, when you call a specific phone number, you get a specific person. These two have matching phone numbers, so when this person makes a call, it always comes to this receiver. Simple, but that's kind of the way it works. Now, all this does is tell all of your other electronics on board what you're telling this to do. So if I say right turn, this thing goes out and tells your servo, hey, right turn. And it tells it how much. You know, are we 10% right turn? Are we 100% right turn? Are we 50% throttle, 10% throttle? Whatever it is, this is getting your commands from the radio to this, and then this is distributing that to everything else. Now, there's a little bit more to it. This is actually powering your servo and, you know, lights and stuff like that if you have lights connected. But that's kind of getting too far out there. For right now, no. This is the person that's making the call. This is the person answering the call. Now, there are receivers that will talk back to the radio and give it, you know, battery life and, you know, temperature telemetry and all that stuff. But obviously, outside of the basics for newbies. Now, when you're... So for steering, let's start with steering. So your servo is basically an electronic motor with a little potentiometer in there and a circuit board. So that potentiometer is telling, you know, where your servo is. So if I turn this servo manually, you know, there's no power to it. But when it gets power, it knows to go back to the programmed center position or wherever your radio input is at the time. So I'm going to power up this. All this is a generic servo tester. So this is taking place of this, so I don't have to have everything plugged into the radio. So all I do is turn the knob left and right, and that is telling the servo where to go. So we're full right, full left. Now, when you're building your car, the instructions are going to tell you to hook up your radio, get all that stuff done, and make sure your servo is in the neutral position. So basically, let me switch modes. This has a center position finder. So the way the servo gets the signal from your receiver, pulse width modulation is the simplest way to explain this. So when you are at 0, it knows, okay, we're not getting any signal. This is where 0 is supposed to be, or where 0 is determined. You can change things on your radio to trim it and move that 0 location here and there. But basically what you're telling it is, okay, no signal, 0. That's where it's supposed to be. And then as you move the steering wheel, you say, okay, 10%. Now what that does is it sends a signal to the servo, and think of it as peaks and valleys. Peaks and valleys. So this thing says, okay, 10% equals this much peak and this much valley, and this much peak and this much valley. And it sends that signal out. And as long as you hold that 10%, this thing is going to stay at exactly that 10%. It understands, you know, with those peaks and valleys of the electronic input, that it says, okay, I'm at 10%, and the little computer circuitry, the little circuit board in here says, okay, we're getting told 10%, we're at 10%, we're good. Now, if you move this to 15%, okay, move, and then it holds. This is designed to move and hold whatever position you tell it to. So if you want to max out a right turn and keep that right turn going, it's now sending, you know, short little pulses or longer. I don't, be honest with you, I don't remember whether the long pulses or the short pulses are, you know, left or right. But basically, from 0, you're saying you have 1 through 100 of pulses. And then from 0, you have 0 through negative 100 pulses. So when you're saying plus 91, it's going to turn to the right 91%. If you're saying negative 83, it turns to the left 83%. That's how the electronics are talking to each other. So the radio tells the receiver 50%. The receiver sends out a signal to the servo with that pulse width modulation thing, the little sine wave, saying 50%. And your servo is going to hold that until it says otherwise. So whatever you're telling this to do, it is telling this to do physically with an electronic signal. Hope that makes sense. It is a little confusing. I don't have charts and graphs and all that stuff. But basically, when you're building your kit, it wants you to zero the servo. And by doing that, you are now setting that neutral point that it's going to go back to, because you don't want to start off with, your servo like this, and then that's your 0 point. Because when you turn your radio on and you get all your gears and your stuff built, you have your tires like this because that's the way you built it. But when you turn the radio on, all of a sudden your tires turn to the left. You have to take this back off, put it back on to where your tires are centered, and then you can use your little adjustments on the radio to fine tune it to get your tires perfectly square or perfectly straight. And then this also has a little mode where it will cycle full left, full right, full left, full right. So basically it's going from, I can't remember what it is. I don't remember, it was 256 or something like that. Computer numbers stick in my head, but say it's 0 to 256. I don't remember exactly. But it goes from 0 to 256, then 256 to negative 256, then negative 256 to 256. It's just going through that number chain back and forth, back and forth. And the nicer your servo, the faster your servo, you'll get a smoother range through that. Now, you can hear on this one, it is not perfectly smooth. This guy's that's because these are super cheap servos. These things are like $4 a piece. I don't expect them to be buttery smooth. I don't need them buttery smooth. But if you had a $50, $60 servo, yes, it should sweep left and right and be absolutely smooth. You shouldn't feel any little bit of jitter or anything like that. All that is just the circuitry, and the motor in this isn't as refined as a lot of the other nicer ones are. But again, like I said, for what I do, I don't need that. So that's pretty much steering. You're using those signals to tell the servo what to do. Now, the exact same thing happens to your speed controller. You tell the radio full throttle. That tells the receiver, hey, speed control, full throttle. And what this does, it takes that signal into this wire and runs it through here, and then sends power out through these leads to the motor. This one's a little confusing because it has 3 wires. So we're going to go back to this guy. So basically, for your ESC, you have battery input. So this is where your main battery pack gets plugged in. So you plug this in. Obviously, these aren't the same fittings, but you plug this in. So since this is an all-in-one, it doesn't have the wire. This wire normally goes out to your receiver. The power going to your receiver comes from this wire. Long story short, there used to be, you guys to have 4 AA's to power your receiver. All this did was get the signal from it. Now, your power for everything comes from this battery. Comes into this, gets split. This sends out to your receiver where it's plugged in. So this would be plugged in to channel 2. And for you guys that don't know, the fun little saying to remember what channel 1 and channel 2 is: 1's to turn, 2's to burn. So 1 is your steering, your turning, and 2 is to burn rubber. So that's your, ESC, which is going to power your motor, which powers your tires, burning rubber. So basically, the receiver is telling your electronic speed control how much power to send out to your motor via the battery. So we're going to go back to this one real quick. So now the receiver has told the ESC, give me 50% throttle. So this ESC does not send 50% power to the motor. That would kind of make sense, but what it actually does is there are high frequency switches in here, little electronic switches. They used to be MOSFETs, then they were HyperFETs, and I don't know what the actual term is for them, but they're MOSFETs. It basically turns on and off at a frequency. So at 50% throttle, say you're giving it 50% frequency, which is basically going back to that little sine wave, that little pulse width modulation, on, off, on, off, on, off. You're telling the ESC to turn the motor and then turn it off, turn the motor, turn it off, turn the motor, turn it off at an equal pace. So you're 50% on, 50% off, 50% on, 50% off. Now you go up to 90% throttle. Now you're 90% on, 10% off, 90% on, 10% off. And it does this super, super, super fast. Thousands of times a second. So you are not, unless you're trying to go very, very slow, you can actually sometimes hear the whine of the motor going. What that is those little pulses of electricity coming into the motor and trying to make it turn. So it's kind of got that hum to it, and you can hear the individual little as those pulses are coming through. Now, the faster it goes, you're not going to hear those because they're majority on, and the motor's making noise, the gear train's making noise, all that stuff. So you're not going to hear it. But at low speeds, you can a lot of times hear it kind of whining, trying to get the motor to go because it's sending out 10% on, 90% off, 10% on, 90% off. So it sometimes doesn't have enough to get it moving. So it's just kind of like dead whining. But basically, that's what's doing the speed control part of this, is those tiny little switches turning everything on and off, either very slowly or almost all on. So 100% throttle is just like, okay, send all the current. I am sure there's still switching going on at some point in here. Again, I'm not an expert, so this is layman's. I'm trying to explain this the best I can to not get into the weeds. So essentially, you tell the radio 50% throttle. The receiver tells this 50% throttle. This then sends 50% power via going 100% 0, 100% 0, 100% 0, 100% 0 at those predetermined, wavelengths. So you are always sending full power to your motor. It's just in tiny little micro blips. So it's not getting full power all the time until you say, give me full power. And then this is now basically a direct connection to this almost. Hope that makes sense. Now, Craig did cover batteries briefly in his, and I agree 110% with what he said. Your first RC kit, I would suggest getting nickel metal hydride packs. They, especially for Tamiyas, they fit in every Tamiya, or 99.99% of the Tamiyas. Sometimes you have to put a little spacer to make the newer packs fit. The advantages and disadvantages of both. Advantages of this, these are pretty much stupid proof. You can forget to charge them and leave them dead flat, come back, it'll take a charge, and shouldn't be no big deal. You can leave these fully charged, and when you go to use them, some of the power has dissipated. Overall, these are very, very kind of tough to kill. Not impossible. Many people have done it. But it's usually the duty cycle, while it's in use, is more damaging than, forgetting to charge it or leaving it charged up. This, on the other hand, these have to be cared for a whole lot more. These have to be put on a storage charge. You can't let these things go down to a very low charge, and you do not want to leave them charged up fully. So basically, when you leave this pack, you want each cell about 3.8 volts per cell, and it could be 2 cell, it could be a 6 cell, it could be an 8 cell. You want each cell in there to be right around that 3.8 volts nominal voltage in there, to where the pack is basically at rest. If you leave it charged, you're basically leaving this little pent up thing of anger and aggression that just wants to unleash power. And that's dangerous, because these things have been known to catch fire in either ends, undercharged or fully charged. So these you do have to care for a whole lot more, especially not running them down fully. So these you can run till the car stops. And it depends on your speed control. A lot of speed controls will finally cut it off at a minimum voltage, just so you're not damaging anything. But on the old cars, you could run this thing till it just stops moving completely. let it cool off, charge it back up, it's good to go. This, if you run them down till your car stops moving completely and there's no protections for low voltage cutoff, this thing is liable to just catch on fire. The battery chemistry in these gets very violent and upset when they go below 3 volts or so. And again, leaving them charged, you're just kind of leaving this pent up little angry thing here. Now, the bad thing with nickel metal hydride is you're limited to capacity and output. So these, as with all rechargeable batteries, when they're charged, they're well above the 7.2 volts that these are supposed to be. This fully charged is going to be about 8.4. The nominal charge in here is 7.2. So this will go from 8.2 down to 6 volts or so before you start having issues with your car. These are 3.7 volts per cell. So a 2-cell pack, which is normal comparative to this, you have 7.4 volts. Now, the great thing about these is you can pack a lot more capacity in a 7.2 pack than you, or 7.4 pack than you can this 7.2 pack. Just the design and chemistry of these batteries don't have the output, they don't have the capacity and punch that these do. But these, I'm not trying to talk you out of them, but these do require attention and upkeep and maintenance. You know, you go check your batteries monthly to make sure that none of them are draining, none of them are puffy, and, you know, special ways of getting rid of them after that. These, throw it on the shelf, come back to it 6 months later, stick it on charge. It'll probably be just as good as it was the last time you ran it. So I do agree 100% with Craig on that, you know, there are advantages to starting out with nickel metal hydride. Now, real quick, the evolution of electronics and safety and all has been greatly upgraded over the years. So this and this are the same thing, basically. This is an old Tamiya CPR unit. So this has the electronic speed controller and the receiver all in one package. This is where your little crystal would go into, and you plug in whatever frequency your radio was on. And this is also an ESC and receiver in one. Much, much smaller, much more compact, lighter weight, and this thing outperforms this thing every day of the week. So things have evolved a lot. And like I said, these are mega cheap servos. This is comparative to probably 90s tech in servos. It just has metal gears and stuff. The new servos, the digital servos that are out there, they have brushless motors in them, tons of torque, tons of speed, tons of power, perfect hold. You're not going to quite get it in this, but these, for $4, you put it in there. If it lasts 6 to 8 months, you put another $4 one in there and run it for another 6 or 8 months. For me, they work great because I have all these cars that I put radio gear in. So putting a $50, $60 servo in each one is outrageous. So I hope that helped explain some things. Real quick, I did want to mention on the mechanical speed control, I did mention that it had a low, medium, and high setting. Some of them were just 2, some of them were 3, some of them were kind of progressive to where it had, you know, dozens of stages going up. It depended on the ESC. But basically, for this one, and for instance, simple explanation, full speed, you're dumping all your battery power directly through this out to the motor. Now, in medium speed, you're putting about 75% of your battery pack through this out to the motor. The other 25% is getting burnt up in heat in little resistors that these had on there. Little white bars had coils in them, and basically that resistor converted excess electricity into heat, and it just bled off that extra power. And then low, you're looking at, 40, 50% power going out to your car, and the other 50, 60% getting dumped off to the resistors, causing them to heat up and bleed off the energy. So these were much less efficient than something like this, because this is not bleeding off any excess voltage. This is just telling it, you're only on 10% of the time, you're off 90% of the time, to where this, you're just sending all that extra battery power into the resistors. This does have a heatsink on there because those little MOSFETs in there get very, very hot because they're turning on and off, 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 and off thousands of times a second with this full chunky battery pack blasting voltage through it. So that's why the heat sinks are on here. Now, your servos, a lot of companies are going to aluminum cases because the demand on modern servos is much, much greater than it used to be. So they're using that aluminum case to bleed off excessive heat built up from the motor and stuff in there, because any type of electric motor is going to create heat, and the more amperage and the more voltage you're throwing at something is the more heat it's going to create during use usually. Okay, I have rambled on enough. I hope any of the new people watching this, hopefully that cleared up some of the things. Now, I'm not going to go into, basically everything I talked about today was brush motors. I didn't talk about brushless motors and brushless systems. That's a whole other can of worms. I am not an expert in that field. I just know kind of what to get for what I want it to do. Other than that, the technology is well over my head. So for specifics on motors, and especially brushless motors, how they work, how the brushless ESCs work with those, I recommend you guys go over to Holmes Hobbies YouTube channel, search around in there. John is phenomenal about explaining how all of that technology works. Some of it, again, is well over my head, but that will give you more of an explanation. He does a really good job, and he's been designing motors and speed controllers for a long time now, and servos. So he's kind of a jack of all trades for the RC Electronics. Okay, anyway, that's it for me today, guys. I'm sorry it was kind of a long, talky one, but I hope that helped explain things. I will try to edit in some visuals to go along with it to hopefully, have you guys see what I'm talking about with the pulse width modulation and the frequency changes and all that stuff. So hopefully that helps. Anyway, guys, as always, everybody be happy, be healthy, be safe. I will catch you guys on the next one. See ya.